Hello, my name is Wanjiru Mambo. I am a senior here at Meredith College. I will be graduating this May. I am majoring in computer science with minors in data science and applied mathematics. I am also an international student from Kenya, and my background being from Kenya is what inspired my research project, which is about a machine learning-based approach to predict the user engagement of a tweet during an election season in Kenya. Thank you so much for being here today, and special thank you to Dr. Lada, who has served as my advisor throughout my research project. The goal of my research was to determine the main topics that Kenyans were discussing on X, which was formerly Twitter, as they prepared for the 2022 general elections, then use these topics as inputs to a machine learning model, and then use the model to predict the level of engagement of a tweet. The reason we are interested in measuring the level of engagement is because it can help us gain insights that can help aspiring presidential candidates and other political leaders to prepare for the upcoming election season. In order to better understand the data we were working with, some exploratory data analysis was performed. The dataset that was used for this project was obtained from Kaggle, which is an open source platform for data science enthusiasts and where you can also get datasets for free. I used Python for my analysis throughout my project. The original dataset had 11,723 rows and 16 columns or variables, which can also be called features. Each row within the dataset represents a unique tweet. The tweets within this dataset were collected between May and June in 2021. Here is an example of a table showing some of the variables that we were using in our dataset. To the left are examples of variables that came with the original dataset, and to the right are examples of variables that we generated using already existing variables. Tweet engagement is one of these variables that we generated, and it's the one that measures the level of engagement of a tweet, and is also the one that we use as our response variable. Simply, the tweet engagement is a value that's calculated using the formula shown, and it's computed as a percentage. It's possible for the value to be 0%, which means a tweet received no engagement at all, and it's also possible for the value to be greater than 100%, which means that it was a viral tweet. Once we calculated the tweet engagement variable, we went ahead and plotted our visualization to better understand the distribution of the variable. We can see from the histogram that the distribution of the tweet engagement is very right-skewed with very extreme outliers. If anything, we cannot even tell the range of the values. We can see that there's a maximum value of 941%, which is an example of the viral tweet that I was talking about. In order to account for the extremity in the outliers, winsorization was performed. Winsorization is simply a technique that's used to handle extreme outliers by setting them to a specified percentile value. Before we performed any winsorization, the data was split into training and test sets. The training test set is what was used to train our model, and the test set is what was used to test how well our model was performing on new and unseen data. After we did that, we went ahead and filtered values that were 0% because we were interested in tweets that actually received some form of engagement. After we did those steps, we performed a 90% winsorization, which is essentially setting values below the 5th percentile to the 5th percentile value, and any values above the 95th percentile to the 95th percentile value. Winsorization was performed on both the training and the test sets. After winsorization, we can see that the distribution of our tweet engagement variable improved significantly. We can see that it is very easy to now tell the range of the values. And our maximum value improved from 941% to 9%. The small bar the small bar to the very right of the histogram is where all the outliers were set. Anything above 9% was set to that value. So once we handled our tweet engagement variable, we went ahead and performed topic modeling, which is generating topics from the tweets. In order to perform topic modeling, the first step is to perform some text preprocessing. This is an example of a step-by-step process on what was done. We first converted the text to lowercase and then normalized it, which is removing any noise in terms of punctuation, numbers, and so on. Then tokenization, which is splitting a text into individual words, and then removing stop words because they don't really add any meaning to the text. And then finally performing lemmatization, which is narrowing down a word into its root form, keeping in mind the context of the word. Here's an example of a tweet that I randomly selected. We can see the original tweet and then how it looked like after it was pre-processed. An example of lemmatization is when needs turns into need. An example of when context is accounted for is when tired remains tired and punctured remains punctured. After pre-processing, we can see that the text is very simple and straightforward. So we went ahead and performed topic modeling, and for this particular tweet, it was assigned the topic thoughts on presidential candidates Raila versus Ruto. Raila and Ruto were the two main presidential candidates that were running for candidacy leading up to the 2022 elections. Here's an example of how we can visualize how one of the topics was generated. Here I picked up the topic that appeared as topic number 1, and I assigned this as top thoughts on Uhuru Kenyatta and his regime. Uhuru Kenyatta was the president that would be stepping out of office after the 2022 general elections. The size of the bubbles indicates the frequency of a particular topic. The bigger the bubble, the more frequent the topic was. The red shaded horizontal bars represents the frequency of a word within the particular topic. Another thing to note is that the closer the bubbles, the more likely a semantic relationship exists. And for the bubbles on the diagonal, those are all the bubbles that were representing topics talking about an election season. Once we performed topic modeling, we were able to come up with 3 main topics, which are thoughts on Uhuru Kenyatta and his regime, thoughts on presidential candidates, Raila versus Ruto, and other. Other is anything else that was not talking about an election. Once we did this, these topics were used alongside other variables to come up with a predictive model in order to predict the level of engagement of a tweet. For our predictive model, we chose to focus on a random forest regressor model because it tends to be one of the best performing models. Unlike a linear regression, it's very hard to visualize or even come up with an equation for a random forest. If anything, it works like a black box. But in order to understand what random forests are, because they're essentially a collection of multiple decision trees, we need to understand what a decision tree is. A decision tree is a sequence of if-else statements to help you come to an ultimate decision, as shown on the diagram to the left, which shows you the process on deciding whether or not to serve. And then to the right is a simplified example of what a random forest looks like. Essentially, we have multiple trees that were selected randomly, and then a prediction is made from each individual tree, and then all those predictions are averaged to come up with a single prediction that serves as the prediction for our random forest. Once we determined the model that we would be using, the next thing was to identify 2 main hyperparameters that we would be using, that is the number of trees and the number of max features. So to do this, we first needed to determine the total number of our features. So these are the total number of predictor variables, which was 23. And then for the number of trees, we went ahead and selected the number of trees that had the most reduced error, as we can see on the plot to the left. So that came to about 230 as the best value. And for the max features value, looking to the plot on the right, pay attention to the pink line. So that's representing the best number of max features, which was 7. So it's the best because it's the one that had the most reduced error. So we went ahead and used these values to build our random forest. And in order to assess the robustness of our model, we needed to take into account the root mean squared error score and the R squared score. So the root mean squared error score is the difference between the observed values and the predictions that our model made on the test data. And for this value, we came to a value of 0.5492%. It's expressed as a percentage because our tweet engagement score was also a percentage. The R squared score is a measure of goodness of fit for our model. So for this one, we got a good score of 0.9470. And ideally, with a good model, what you're looking for is a low root mean squared error score and a high R squared score, as we were able to achieve as seen here. The next thing to do was determine what features were contributing the most to our model or even to our tweet engagement variable. We can see that user followers, favorites, tweet count by user friends, and retweets were and accounted were the variables that were contributing the most. We were hoping that we would be able to see some of those topics approaching here, but unfortunately, we were not able to do so. However, that does not mean that our project was unsuccessful. If anything, we have one key takeaway, which is that aspiring presidential candidates and other political figures should consider posting messages that relate more with people, because this is how more people will be able to engage with them. So if they post something people can relate with, that tweet will receive more likes, more retweets, and that message will be passed across to more people. Another thing these leaders can consider doing is tweeting more frequently, but also making sure they're tweeting relevant information. This is also another way that their message will be able to be passed across to a big number of people. Moving forward in terms of opportunity for future research, I will probably focus more on the tweets collected among presidential candidates and political leaders, because we can be able to get more specific topics from that, as well as eliminate any noise that might come with the data that's generalizing to a bigger population. Thank you so much. Bye.